Okay. So the way I like to think about this is with the geometric interpretation to start with. So if I have a binomial, which means I have two things, I can multiply it out looking at a geometric shape. Now, is that a square? Why is it not a square? Because it's plus 2 and plus 3, so that's a rectangle. Right? So it's my geometric rectangle. What we're going to definitely look at down the road is a square. But I can multiply it all out and expand it and add it up and get that. You could also FOIL it and you get the same thing. However, what if we're just given that? And I want to solve for it. Well, we could factor out the x, right? We could have x times quantity x plus 8 and solve it that way. But let's say we didn't see that. And I wanted to build a geometric model of it. Well, there's the start of my square. If I take this 8x, how do I need to divide it up so that I can build a square, not a rectangle? What piece is going to go? How much is going to go there and how much is going to go there? Half and half, right? So I want 4x's and 4x's, otherwise I'm going to get a rectangle. So I take half and half. So it looks like x plus 4 and x plus 4. And which piece is missing? Well, my square is not complete because I don't have that piece. So what's going to have to go in that corner to make it a square, to complete it? 16. So that's going to be my 16. And so I want to add that. I want to have this in my equation, but I don't have it. But I put it on the left side. What do I have to do to keep my equality, to keep it balanced? I can't just add 16 to one side. I have to do it to what? Both sides. So I'm going to add 16 to both sides. This factors into x plus 4 squared. That's why we built it this way. So I have this factor twice. All right? Well, if I want to get the x by itself, what's my inverse operation for squaring something? What undoes squaring? Square rooting it. So I square root both sides. And x plus 4 is plus or minus 4. And it's key that I get those two equations in there. Because I don't know 4 times 4 is 16 and negative 4 times negative 4 is 16. So I get two answers. The last step would be to subtract 4. And I get plus or minus 4 plus 4, which is negative 8 or 0. Which we could have seen if we'd factored this from the beginning. But we're not always going to have that opportunity. Because what if this was x squared plus 8x plus 1? Right? We wouldn't be able to factor it. We wouldn't be able to set the factors equal to 0 because I'd have a 1 there, which would throw it off. All right? Thumbs up if we're good with that example. Understand what that looks like? Where the completing the square came from? Okay. So I took half of the 8x and I put it on both sides, and then I squared that number. So now we're on your sheet. So if I'm given x squared plus 6x plus 2 equals 0, the first thing we want to try to do is, does it factor? So I'm looking at things that multiply to 2 and add to 6. Well, the things that multiply to 2 are 1 and 2. Is there any way that those are going to ever add to 6? No. All right, so we still have solutions, but we don't have nice solutions. We don't have integers. But we can use completing the square to figure them out. So if we start building our square, there's my x squared. And then I have 6 x's that I want to distribute. So I'm going to put half of them here and half of them there, which is 3 x's. And so my sides become x, 3, x, and 3. And then to complete the square, I'm missing a 9. So if this 2 was a 9, I could have factored it from the beginning. But it's not a 9, it's a 2. But we can use a little bit of algebra and think about, what would I want there? I want that to be a 9. I can't just add 9 to one side. What do I have to do? I have to put it on both sides. So I add 9 to both sides. And I know someone's going to ask the question, so I'll answer it now. Could this be a 7? Yeah, because that would still give me 9 here. If I put 7 there and 7 over here, that would still work. But it's easier if you just think of, this is the piece I need, that's the piece that goes there, and solve it from here. All right, what's my next step going to be? So now I have something that's factorable. So this is going to factor into what? X squared plus 6x plus 9 is what? Factored.
X plus 3 squared.
X plus 3 squared, because we built it that way, right? It's this times that. So it turns into x plus 3 squared. What's that? I'm not looking at the 2 yet. All I'm looking at is that. So I want to try to get that into a factored form. We'll see what happens with the 2 here. So that becomes, the 2's still there. I haven't touched the 2 yet. What do you think my next step's going to be? Subtract 2. And so I'd subtract 2 and get 7, and then I take the square root of everything. And so I get x plus 3 is plus or minus root 7. And so I subtract 3 from both sides. And those are my 2 answers. So those are going to be my roots. Are those nice numbers? No. But they are my irrational roots. Alright, so my process, again, all I did is I ignored this 2 because it doesn't factor. I said, what would I need to have to complete this square to make it a factorable binomial? I have to add 9 to both sides. I do that. I write this in factored form, and then I solve. Yes?
Wait, which ones are the roots? Isn't there only one solution? Oh, so the roots are negative.
So it would be negative 7 minus 3, negative root 7 minus 3, and then positive root 7 minus 3. So, and then I could plug it in a calculator and get an approximation, but that would be my exact answer. So I'm getting 2 roots. Okay. Thumbs up, sideways, or down on that. We understand what we did? So, okay. It'll take some practice. All right, I want you to try this one down here. Which one? The x squared minus 14x plus 19 equals 0. I can't remember what I did. Okay, so we start with that. And I want to look at just this piece. Well, first off, I'd ask myself, does this factor? So 19 is a prime number. Only thing that's going to multiply to 19 is 19 and 1, and I can't get to 14 from that. So I'm going to try to complete the square. So I'm going to look at the x squared, and I could build my square, right? So I'd have x squared and then 7x and 7x. Basically half of it, 14 over 2 is half of it. And then square it, which gives me what number? What do I need to add to it to complete the square? 49. That gives me, and if I put 49 on one side, and I wrote it a little bit weird because what we're really doing is we're taking, each time, we're taking half of this value, which we call b, and I'm squaring it. Right? So I do it to one side, I do it to the other. And now I just simplify. So negative 19 plus 49 is 30. I take the square root of that, and then I add 7. Alright, did I do it right? Looks good. Alright, so if you like building the geometric models, then please do so. It helps me remember why I'm doing what I'm doing. But you can always take half of this value and square it and add it to both sides, and you'll be guaranteed that you're going to get something that's factorable. All right. What would happen at the bottom here? Did I do this one? When I have an odd number. Is it still going to work? Yeah. Okay. So let's say I built it, x and x is x squared, and then I have one x. So what's going to go here? If I divide that x up, half x. So this is plus a half. So what am I missing in order to be able to complete the square?
Quarter?
Quarter. So I'm going to need to add a quarter to both sides. I think I did this one. Yep. So I do that to both sides. I add my quarter. And then I know it's going to factor because that's why I picked this. It's going to be this squared. So it's x plus a half squared. And then I solve. I bring all my numbers to the other side. And then I skip doing the rest of it, apparently. And then I take the square root, right? What's going to be the problem? Well, not problem. Let's just do it. X plus 1/2 equals negative 4.75. Before 2 days ago, when you did this, we had no solution, right? What type of solution do I have now? Complex. I have an imaginary number in there. So I have something with I, right? I plus or minus I root 4.75 minus 1/2. Yes, sir?
Don't you add 5 to get rid of it?
I already have, ooh. Yes. So I copied it down wrong. So this should be a minus, right?
Yeah.
And then okay, yes. So that would be plus. So I wouldn't have complex roots if I'd written it down correctly. But is it okay if I get complex roots?
Yes.
Yes. All right, and we're going to look at what that means with the graph down the road. All right. So one problem that we're going to find is we've had them where my coefficient, my a value in front of x squared is always 1. And if it's not 1, we can make it 1. How do we make it 1?
You divide by itself?
Divide by whatever it is, right? So if I have a 2 in front of the x squared, I'm going to take everything and we divide it by 2. And now I have it in a form that we can deal with. So if I have x squared plus 4x, I need to complete this square. I'm going to take half of this, which is 2, and square it, which is minus 4, and add that to both sides. So I get x squared plus 4x plus 4, and that factors. And we can solve from there. Okay. I don't know why I didn't work them all the way out. I guess I was being lazy. So we take the square root, get plus or minus root 14 over 4, and then subtract 2 from it. All right, the next one, and then we're going to look at the quadratic formula.
Wait, would be like radical 14 over 2?
Yes. So the next one, same idea. I'm going to take half of the 2 and I'm going to square it and add it to both sides. And here's where I'm going to get a negative square root. So I get x plus 1 squared is this, equals negative 9. I do the same thing that we did before. Is plus or minus root negative 9, which we now know is plus or minus 3i. And so x is plus or minus 3i minus 1. So I get complex solutions to my quadratic. So we have different things that can happen, right? We can factor it and get solutions that are integers, and that's great because that's easy. We can complete the square, and we can either get rational numbers, we can get irrational numbers, or we can get complex numbers. All right. We doing okay? Okay. We'll get some practice. All right. This, again, is one of those that I know you've had before, and I know it's been a long time, and I'm sure the way that it made sense before is you need to practice with it. Okay? So we're going to have lots of time next week to practice with it. We'll have some time today. All right. I don't want you to write this down. I just want you to look at it. So we have this thing called the quadratic formula. That I'm sure you have a nice catchy jingle of how you remember it. And all sorts of different acronyms that people have come up with in mnemonics. But basically all we do is complete the square for a general case. So if I take this, I need to first off get the coefficient on x squared to be 1. Well, how am I going to do that? Divide everything by what? A. So I take this big mess and I divide it by A. And now what I need to do to complete the square is I take half of this, B over A, and I square it and add it to both sides. I brought the C over A to the other side and I added it to both sides. So I've kept my equality. What is this left side going to factor to? Let me draw you a picture. This is x and b over 2a. Right? So it's x plus b over 2a squared. The other side's still the same. What's my next step if I want to solve for x? I need to get rid of that square. So what do? Square root it. After I combine those, keep working on it. Plus or minus the square root of b squared minus 4ac all over 4a squared. I know. I simplify. I break up my square root. The square root of 4a squared is what? 2a. Plus or minus, and I have a plus or minus up here already, so we're going to account for that. So this will be all over 2a, which is nice, because b over 2a is on my left side, so I bring it to the other side. And I have the same denominator, so I can add those fractions. And I get negative b squared plus or minus the square root of b squared minus 4ac all over 2a, which is your friend quadratic formula. Okay? So